Okay, so let's go to question number 4. Take note that every question we have handled, question 1, question 2, are each for what? 8 marks. So if it has A and B, likely the marks will either be spread as 5, 3, or 4, 4. So for this one, it's just one question, so which means that everything will be what? 8 marks. It's a test of formal geometry. So let's try to draw the diagram. This is what you have. I like formal geometry because it's one aspect of maths that strengthens the imagination of a student. So this is Q, this is R, this is P, this is S. Take note, I always like to draw while my camera is on so that you practice, you are used to the drawing process. This is 13 centimeters, this is 4 centimeters, and this is 3 centimeters. So let's read the details and be sure that I've done it right. In the diagram, PQRS is a quadrilateral. PQRS, there's an order in which you name parallelograms or shapes. You either name them in the clockwise, anti-clockwise manner or in a clockwise manner. All these are taken care of in my grade 10 playlist of geometry, points, lines, and angles. All those are well dealt with there. Now, the next thing you're told is that angle PQR is 90 degrees and it's also equal to what? PSR. So this is 90 degrees and this is 90 degrees. So once you see 90 degrees in any diagram, one thing, two areas that should be coming to your mind is one, is either you're talking about using Pythagoras theorem or you're using trigonometric ratios. Come again. Every time in a diagram you see 90 degrees, two likely topics or two likely solutions or outlets you would have, whether be what? Pythagoras rule or what? Trigonometric ratios. So that's what you should take note of there. Alright. Now it says find the area of the quadrilateral. Find the area of the quadrilateral. Okay, fine. Now, so to find the area, we need to have what is called the base. Area is what? Base times what? Base times height. So if you look at this diagram here, if I turn this diagram, because crucial to my diagram is this one. The question says find the area of the quadrilateral. Find the area of the quadrilateral. Now, crucial to my diagram is this 90 degrees. So the next thing I need to ask myself now is, where is my base? Where is my base? Now, there are options for what you can do. I'm trying to be very careful. These are questions where sometimes in the hall you're asking yourself. At a glance, I would have just said area is what? 3 times 4. That's what I would have just said. 3 times 4. But I'm asking myself a question. Why would the examiner go through this trouble and at the end of the day just pick out such a very simple question? So to clear my doubts, I'm seeing 90 degrees here, I'm seeing 90 degrees here. So there's something that just crossed my mind, and that's what I'm going to do. I'm going to call here X, I'm going to call here Y. Because this is a quadrilateral and it's made up of how many triangles? 2 triangles. So you need to be smart. You see the reason why I said I solve the questions on the spur of the moment, because I want to be in the examination hall and see what the examiner wants to do. So I'll call here Y, I'll call here. So using notation as a diagram, by Pythagoras, because that's the rule I'm going to apply now, comma, triangle in triangle PQR. For PQR, area of triangle PQR, that one is very straightforward, will be what? Half times 4 times 3. I don't need to begin to tell half base or whatever, it doesn't make any sense. This will be what? 6 cm. 6 centimeters squared, sorry. Now I've done this one. Now I need to get this part, because this is 90 degrees, I need to get this part out. So I can now say that what? From triangle PQR, x squared will be equal to 3 squared plus what? 4 squared. And that will be equal to 9 plus 16, which means that x will be the square root of 25. That value will be 5 cm. So I now know that this is what? 5 cm. So to get this figure, I need this part. So with that, in triangle PRS, because we are told that it's a right angle triangle, I can now have that x squared plus y squared will be equal to what? 13 squared, because 13 becomes the hypotenuse. So my target is to look for y. Why am I looking for y? Because y is the base I need. So y squared will be equal to 13 squared minus x squared. What is x squared? 5. So that will be 13 squared minus 5 squared. And let me use my concept of difference of two squares here. Let's flip. 169 minus 25, 144. Y will be equal to the square root of 144, and that is 12. So with that settled, I can now look for my area. So area of triangle PRS will now be equal to half of what? X, y. What is x? X is what? 5. What is y? Y is 12. So this will be what? 30 cm squared. So area of quad PQRS will simply be equal to what? 6 plus 30, that is 36 centimeter squared. So you see that this is one of those very technical questions, and if you don't look at it well, you will just answer and think that you have done the right thing. But the little caution I had was I looked at the volume of marks. This is a question for 8 marks, and the examiner will not just set something cheap and just walk away. So this, I think, will be the appropriate way to handle this problem.